Howdy, my name is David and I'm the head of the Solis Rover Project here at UT Dallas. This year we are proud and excited to announce our submission to the 2025 University Rover Challenge System Acceptance Review. This year our rover is robust, effective, and efficient all in one nice package we like to call Leão. This rover, Leão, showcases the culmination of our efforts thus far in the 2025 season.
Hello, my name is Jacob.
And I'm Abdullah.
And we're the mechanical leads.
In order to complete the delivery and equipment servicing mission, we were tasked in designing and developing a drivetrain and servicing arm for our rover.
The drivetrain consists of aluminum parts, which keeps our chassis strong and lightweight. Our suspension utilizes a differential bar to help us retain contact across uneven surfaces and keep our equipment stable. Our wheels are designed with a modular approach, which allows tire testing to be easier and tire repairs to be even faster.
For the arm, we use a 4-bar linkage system due to its simple and efficient design. Our arm and effector work together to allow us to carry our payloads and perform equipment servicing tasks. Similar to the drivetrain, the arm uses an aluminum frame to keep it lightweight while also maintaining its rigidity.
Hello, my name is Pablo.
And my name is Pablo.
And together we are the leads for the embedded team.
For the autonomous mission, we use stereoscopic vision to create a 3D map of the rover's surroundings. This is for obstacle avoidance and path planning of the rover. For the object detection objectives, we are fine-tuning our own YOLO model, specifically for the orange rubber mallet and water bottle, and integrating it into our ROS2 nodes. We communicate to our rover over 2.4 GHz and 433 MHz, utilizing our handband radio for long-range and non-line-of-sight communication.
And on the base station side, our website shows the data published from the rover in a streamlined format and displays the rover's camera feed, GPS location, and orientation.
My name is Luke.
My name is Suj Aditya, and we're the leads of the science team.
The science payload consists of a subsurface regolith acquisition system and a testing suite to perform life detection analysis.
Using a robotic gantry, augers drill into the terrestrial surface to convey subsurface samples to the rover. Individual augers drill at each site to prevent cross-contamination. The samples are then pumped into the testing suite via peristaltic pumps.
Our testing is performed by conducting a BioRay protein assay and an FDA hydrolysis on the samples in the carousel. The colorimetric results are confirmed by our visible spectrometer. After this, a Raman spectrometer evaluates the sample's mineral composition.
The Solis Rover Project has been made possible by the UTD Comet Robotics program and by contributions to the SRP Impact Fund by supporters like you. Thank you.